So I was saying that once you connect to the wiki for these workshops, this workshop series, part of the Data Lab workshops that we're going to be doing every semester, and we are iterating. So this workshop is going semester by semester, and we try to teach all the basic skills you need for doing data analysis and data modeling using Python tools. So the first tool that we're going to be using is going to be Jupyter Notebooks. And you saw in the previous talk, Jeff was using a Jupyter Notebook. So let's go into this link, and I'll share the link in the chat. So control it. So this is the notes for Jupyter Notebook. It's just github.com/uva-datalab/workshops, capital W, /wiki, and then choose Jupyter Notebooks. Okay. So for the people in the room, this is the, well, this is one of the links that work. Okay. All right, so what are Jupyter Notebooks and why we use them? First of all, we have been talking about reproducibility in science, and when we are doing some research and we find someone else's work, what we would like to do is try to reproduce their code using their data and getting the same results. So that's reproducibility. And Jupyter Notebooks is a good tool in order to propagate our research by including our code and our data in order that other people can reproduce and obtain the same results. So that's the idea of the Jupyter Notebooks. And the Jupyter Notebooks, you can work not only in Python in Jupyter Notebooks, but also you can work using R or using Julia and some other languages. It's a very common tool right now. And also it allows me to work with code and also to visualize some plots or some graphics, and everything is going to be self-consistent, that we can follow like a storyboard. Okay. So Jupyter Notebooks comes from a project called Jupyter. And also this is how the interface looks. And we're going to be showing you how to use a Jupyter Notebook from scratch. And also you will find that following this link, there are many applications, scientific applications, where people have used a Jupyter Notebook. And then once you find a Jupyter Notebook example, that you can just download it and execute it, provided that you have all the libraries needed for that task. So Jupyter Notebooks, you'll find examples in artificial intelligence, machine learning, biology, chemistry, physics, earth sciences, geospatial analysis, etc. And the Jupyter Notebooks can run on your local computer, or you can run Jupyter Notebooks online. We're going to go to the online version for Jupyter Notebooks, and we will find that there are many options, at least two. One of them is Google Colab, and once you have a Gmail account, which everyone has, if they're U of A student or faculty staff, then we can use our Gmail account to run a Google Colab. Also, another option is MyBinder, and it's a similar thing, except that what you run or what you end up running is a Docker container, and then it's just like having a virtual computer on your own, and be running Jupyter Notebooks. Another options, if you have an account over Cybers, you can find that you can run a Jupyter Notebook over there. or if you have an account over U of A HPC, then you can also run a Jupyter Notebook. So Jupyter Notebooks are very common everywhere, and you can run them in different environments. Okay, so let me start a session over Colab. So let's go to Colab. And then I ended up in Jeff's account. Sorry, Jeff. Let me cancel, change. And then we log in. And then ask all the requirements. I need to open Gmail. Okay, got it. Yes. And then, okay. Okay. So now I'm in. Okay, so I'm using my Gmail account over Google Colab, and it has all my previous Jupyter notebooks. You see, and I've been using Google Colab for some years right now, and it's going to be similar to what you have in your Google Drive or your Google Docs and spreadsheets. So I have all the different Jupyter notebooks that I have created, and I can do, let's see. So I can create a new notebook, and let's start from there. It's going to be, again, some untitled Jupyter notebook. And if you hover over the name, you can change the name of your Jupyter notebook and save it. So it's gonna be called Intro to Jupyter Notebooks. And the file ends with IPYNB, which means Interactive Python Jupyter Notebook. So you always find the same extension when it's talking about a Jupyter notebook. All right, so I have created a new notebook. I have renamed it. I can just file save. And so you're saving a copy into your Colab drive, right? And then you will see that in the interface you have two options. You have the option for writing code, or you have the option of writing text. And these are the types of cell. This is a cell, which is here. This is a code cell. So if I say print, and I'm going to write in Python. So I'm just going to ask the Jupyter notebook running to print hello world. And to run it, I execute the cell by pushing the play button, or I can just do do Shift plus Enter. It works both ways. I do Shift Enter, and it's the same as executing the play button. And then it's thinking or executing, and it will come back with an answer. And the answer, which is the output, is hello world. Okay. And I'm running a Python instance. So you can see here, let's see, view resources. And I'm using a Python 3 Google Compute Engine backend. So I'm running Python. And I have almost 13 gigabytes of RAM. And I have about 107 gigabytes of disk space in this Google Colab. So when I save this Jupyter Notebook, it's saved in the Google Drive. And then I have additional files here or directories where I can store something. And for example, I have some previous data. I have CSV files, and also I have a JSON file and a README Markdown file in my drive. Okay, so this was a code cell. The next thing I want to do is a text cell, and what I so this is a text cell, and for doing texts in a Jupyter Notebook, I can combine code and texts, and the text can follow the format which is called Markdown. So if you haven't heard of a language which is called Markdown, and it's the same language that you can use over GitHub to write documentation. So it's very straightforward. Let me go here, close. So this is a Markdown language, and you saw that I have a font sign at the beginning. So that means a large title. Then I can say a subtitle. And the text cell is split in two parts. On the left-hand side, I have the code. On the right-hand side, I have how it's going to be looking, or what you see is what you get. Then I can say as many levels, sub-levels you want to go. And then I can do lists. For example, item 1, item 2. It's just a dash space. And you see that on the right-hand side, I have the bullet points. I can do enumerated items. If I just say 1 dash item, and it will enumerate. I can do 1 item again, and item 1. And then the system automatically will be numbering automatically my items. This is my item 3. Then this way, I don't have to be doing all the accounting. So what if I want to change, the order of my items? So I go and cut and paste. And then automatically the system will enumerate them again. Also, Markdown languages understands LaTeX. If you use LaTeX for writing equations, you also can do the LaTeX environment. dollar sign, it's an equation. So you can say some fraction, and then curly brackets, oh, and say df dx equals pp, and then close the equation. And on the right hand side, I'll see the equation written. Okay. All right. So that is the LaTeX notation. And then, of course, there is a very simple editor that is included. So you can use directly the codes for Markdown, or you can use the small menu here. So if I want to write something in bold, I can select the text and then select the B from here, and it will write it as bold. You can see on the right hand side that I have a bold. And the instructions, the Markdown instructions, is just double asterisk, enclosing double asterisk any word. And you can also have italics or emphasize, and you just enclose it between underscore. What else? You can do tables. So this is a table example. So some item, some description. So I'm going to create a table of 2 columns. So, and I will have centered, the first column will be centered, and the second column will be left. Oh, okay. And then I say whatever, Apple, okay. And then I have a table, very, very easy to write. If you can have like a n-dimensional table, just separate everything by the vertical bar, and also the second line always define the format of your table. So one is centered and the other one is left centered. And if you want to do a right, of course, you have to do it like this. But I just added an additional column. So this is column 2 or 3. And then I have to come back here and say whatever. Yeah. So I have a column, a 3-column table. Okay, so this is Markdown. And the object of this, or the goal of these text cells, is that you can combine code and text explaining what you're seeing. And also you can add links. So for example, I can add a link to this one. And adding a link is just square bracket, and then close square bracket. And then the link will be enclosed in parentheses. So the parentheses will, let's say, HTTPS text. And I have added a hyperlink. So if I say open a new tab, it will, well, yeah. Okay. So I just need to have a valid link, but everything is working. Okay. Okay. Say latex. Yeah. So that's the way you handle the links. Or I can just do whatever link here using the editor and select the link and then select the link, and it will do the same thing you were doing before, except that it's going to write for you some part of your link. Okay. Any questions so far? If you're online, you can just unmute and ask, please. Okay.
I kind of missed the beginning of it, Carlos. So you're showing us how to do markdown language.
In a text cell, yes.
Okay, in a text cell.
Yes.
Okay, in terms of just formatting text when you're trying to describe what the code cell is going to do.
Yeah, the code cell is just for running code, like print hello world, which is a piece of code, Python code. And then, or you can have a text cell, which is the other option to write something, right? So, and inside the code cells, you can use the pound sign to make a comment, to write a comment. Okay. And the output is it's shown here with an output arrow, right? And then when I'm done, well, when I'm done with writing the text cell, I also do the shift enter or execute. And if I want to re-edit this, I just go back and double click with the mouse, and it will open again the markdown section, right? And then when you're done, just shift enter. Okay. Another option that Jupyter Notebook allows you to do is once you have a cell, select the cell, and then you will find that there is some arrows here. These arrows is for moving the cell up or moving the cell downwards, or adding a link, and or you can edit the cell. You can copy the cell, or you can just delete the cell. So let's say I have here some garbage, and I can come and delete the cell. It just goes away. Okay. All right. So far, are we doing good with the Jupyter Notebook? Yes.
Yeah. So we're at 3:30.
Okay. All right. So let me go back to the notes. Okay. So when we are going to be working with Jupyter Notebooks, we should be aware all the different Python libraries that are available for us.
Carlos, can you put that link in the chat again?
The Jupyter Notebooks, yes.
Yeah, just the your notes there. Yeah, what is that URL? Just put that in the chat.
Sure. Here. Okay. Oh, right. Control V. Right. So these are the Python libraries which are available, and some basic general knowledge is that in Python you have NumPy, which is the numerical Python, which allows you to do any type of mathematical operation. SciPy is scientific Python. It's just a collection of algorithms for doing scientific computing, numerical computing. Pandas is going to be your Python library for doing data analysis or data analytics. And then, so these are for data manipulation. And you have several options in Python for doing data visualization. The most common one is Matplotlib, which is the basic graphics library. And then Seaborn, it's a library based on Matplotlib, but allows the user to write less code and obtain a more functional graphics. If you know LaTeX, for example, LaTeX is derived from text, and we don't write directly in text, we write directly in LaTeX. So Matplotlib and Seaborn have the same relationship. And then if you're going to be doing machine learning, then we have scikit-learn for doing all the classical machine learning tasks or problems. And then if you're doing deep learning, like all these large language models or any other type of like image segmentation, you can use TensorFlow or PyTorch or Keras. So those are the main libraries. We will, along the next sessions from this workshop, will be coming back for every library. So next session next week will be on pandas. So we will show how to read your data sets and then try to clean your data sets, extract information, do the exploratory data analysis, and then create some simple plots. And then we will continue with visualization and other libraries. Okay. So let's try the first notebook, which is a basic introduction to Python. If you are not a Python user, just follow along this Jupyter notebook. We'll open this one. So we will open this basic introduction to Python. And there's something in the chat.
I just put the URL again.
Okay.
Yours was a little incomplete. Okay, which one are we going to again? Which notebook am I launching?
The first one, this one.
Jupyter Notebook examples. Okay.
So we open it and let me close this one, files. Okay. So this is a Jupyter notebook, which is an introduction to Python. And this is a code cell. And this is a text cell. So if I double click it, you will see, well, I need to.
You need to launch it in Colab.
Yes. Open in Colab. Yes, I was in GitHub. So this is the Colab, right? And if I double click on the text cell, you will see all the basic markdown text in order to reproduce the right-hand side window. Shift, enter. So the basic operations in Python is just the plus, the sum, the difference, product, division. There's several types of division. You also have the modules division and also the integer division. Floating numbers, which are real numbers, you just do the basic operations, multiplication, division, exponentials. We have Boolean expressions like true and false. We have the equality, and this is the logical equality. If 5 is equal to 5, it will return true. If 5 is not equal to 5, it will return false. And if 5 is greater than 4, it will return true. And And then we have the greater equal, which is a greater and equal signs together. So 5 is greater or equal than 5, returns true. And then the same thing applies to the less than. We have some examples. This is how we define the variables. So compared with other, oh, sorry. I think I just misspelled. So compared with other languages, we don't have to declare that x is going to be an integer and y is another integer and c equals another integer. We don't have to say that x, y, and z are integers. Automatically, Python, depending on what's on the right-hand side of the equation, it will say that x is an integer, y is an integer, and it's almost as c. Then you can do, if x equals to y, it will print hello. Else if x is equal to c, then it will print goodbye. Else, if it's not, if it's not any of the two conditions, it will print questions. So let's say we execute the cell. Okay, run anyway. And this is the output. Okay, so you can go back and re-edit. Let's say x and y is equal to 1. And then we execute it again. So now the first condition will be met. So since x is equal to y, it will print hello. I just execute it. And the outcome is, or the output is hello. Let's say x equal to c. Let's say y is equal to 0 and c is equal to 1. So now we have the condition x equals to c, so we will print goodbye. So I execute it, and it printed goodbye. Okay, and then you can see it's very easy to program in Python. Nothing major. And if you are familiar with other languages, there's also the loops. You can do iterations until some condition is satisfied. Okay, so we have the for loops, and then it will print loops of 1. So I'm just the best way to learn a language, a programming language, is to have some problem to solve. So if you don't have any need of using Python, there's no need to learn Python. But if you are mandated to work in Python because somebody gave you Python code that does something that you're interested in, the first skill you need to develop is learning how to read Python code. And Python is very popular, has been one of the most popular languages, programming languages in the last 10 years, I'm going to say. And so and Python is almost like reading English. So let's try to read this.
Almost.
I mean, print, what does the print means in English? Well, print.
Print.
And then for I in range 5. So range 5 is a function that also the Google Colab will give you the help command for the function. So if I put the cursor on top of range, it will come back. Just leave the cursor on top of range. It will tell you what type of function it is. So if I say range 5, it will just give me the numbers from 0, 1, 2, 3, 4 without including 5. And then it will print. So it's a for loop. So every time it goes to the loop, it will increase I by 1. And then the second loop, this is the second loop. /n means a new line. So there's going to be a new line between the first output and the second output. The second for loop is going to be range from 10 to 2, decreasing by -2. So this start, the end, and the step size. And also will print I. And then there's the while loop, which is another type of loops. So while I is less than 10, starting with I equals 1, it will print the next I is, and then it will print I. And then it will define the new I as the old I plus 1, and it will execute. So let's execute this. And this is the output. So we have the first loop, which is just printing the sequence of i's. The second loop, printing the i's from 10 to 2, decreasing by -2. And the last loop was while I is less than 10, it will print what's the next I. Okay, so the first thing that we need to do is understand more or less what Python is doing. Okay, okay. Now, Python has different data structures. It has lists, and a list is just an array of something. And in this case, the first list is 1, 2, 3.0, and 4. Automatically knows that one of them is a real number or with decimal, and the other ones are integers. Okay, and then the second one, it's a list. It's a container that has 1.0, the integer 2, the character 3, and the integer 4. So this one is the character for 3. So it's like the symbol on top of your keyboard on your computer. It's a symbol of 3. It's not number 3. So when you print the lists, it will return the contents of the list, and then you can add. But then it will add all the integers among themselves, right? So it's going to put the first list, and then it's going to put the second list, because there is no way I can add 2 lists if they're not numbers, okay? Another example is in Python, in order to load a library into memory, we have to use the command import. So I'm going to import the library NumPy, and I'm going to denote, instead of writing NumPy every time, I'm just going to use the abbreviation of NP. So if I'm going to use an array from NumPy, I have to say NP NumPy array. And then arrays will be different than lists. So the first array is just an array of integer numbers. The second array is a container that has 3 integers and a floating number or real number. And Python automatically will convert all the integers into real numbers or floating numbers. The next one, the S3, it doesn't do anything to number 4, because 4 here is just a symbol, it's not number 4. Also, we have functions to define a range of numbers. So the first one is a range. So we will declare, give you an array of numbers between 0 and 5, and the increment is 0.5. The other one is a linspace or linear space. It will give you 20 points between 0 and 5. So these are basic functions to declare arrays. Okay, how are we doing in time, Jeff?
3:46.
Okay. So I'm not going to finish giving you a Python crash course in the next 5 minutes. But if you have done any programming in your life, you can go back and follow the notes. Just reproduce, play with them, change here, change there to see what happens. Be curious about it. And this will be Python. And when we start analyzing data, well, the first thing that we need to know is how to read a data file, and then see what type of data we have. We may have integers, we may have strings of characters, we may have floating numbers, we may have logical numbers, variables, etc. And we will start working from there. And let's say we read a data set, we identify one column of data, and then like in Excel, we will find a function that computes the sum, a function that computes the average, a function that, so we're just going to be doing the same thing you do in Excel, but doing it with Python. And to do that, we will have to use pandas to read the data sets and to clean the data sets. And then we will use NumPy probably to do some mathematical operations. And for example, here you see there is a graph, and we loaded the other library, which is called matplotlib, pyplot, and denoted as PLT. We have two variables, x and y. X is just 100 points between minus pi and pi, and y is a function of x. The function is sine of x, trigonometric function. And then we define other two functions, y1, other three, four, five functions, y1, y3, y5, and st. y1 is just the function x, y3 is just the function x cubed divided by 6, and y5 is x to the 5th divided by factorial of 5. And st, which is the series, the Taylor series, is just going to be the sum of the terms. And then we will create the plots for each function. And voila, we have the sine function in blue, which is the real function. And we have the Taylor series components. We have x in red. We have the fifth order truncated Taylor series, which is in red, in green, I'm sorry. And then we can see what is the approximation of the Taylor series for the sine function, just adding the first three terms. Calculus 101. Okay, I think so. All right, so this is how we do it in Python. Okay, so any questions? You have the notebook. This notebook is yours. You have running it in Google Colab. And now you can play with it. And you can save, let's say, code. Say, where am I?
Yeah, just a note for beginning Python users out there. It all starts with a need to use it. You need to have a mission in mind. I couldn't go out and be like, okay, I'm going to learn Python. Then I'm going to like tackle my problem. Don't do that. Just what is your problem? Start with that and then work towards from point A to point B solving your problem. Because Python is an infinite, it's a language, you know, there's infinite things you can do with it. And so try to solve your problem. And you learn how to use Python in general along the journey of trying to solve your specific problem. And it just takes a lot of time. And please use chatbots like ChatGPT and Bard to their full extent. So I wouldn't be able to function without them. So that's the plug.
Okay. Okay. once you have your, just to finish, once you have your Jupyter notebook, there's a file. Then we can save your Jupyter notebook in your Google Drive, or you can save a copy on some GitHub repo. So for example, if I say save a copy of this because I want to share this notebook with some of my other co-workers, then I'm going to change the, I'm going to save this Jupyter, and then I select whatever GitHub repository I'm interested in saving, okay? And then you say, okay, and then it will automatically create a Jupyter notebook over your GitHub, one of your GitHub repositories, and it's going to be there. And then you can go back and open it in Collab, etc. Okay, so this, we will be using Jupyter the whole semester, and also in the geospatial workshop, we'll be using lots of Jupyter notebooks examples from different repositories for different applications. So that's my talk today. Any questions from? No? It was very clear? Okay. I'm happy to have a very smart audience, no questions.
I'm just curious, in the house here, you guys Python users in general, or pretty beginner at it? Are. Okay.
Struggling Python user.
Okay. So, okay. My background is in R. I use that a lot because I come from, like, ecology adjacent type work, and R is a little easier than Python. But Python is much bigger and more powerful, and it's such a larger user base worldwide that it's a more valuable language. R is much more niche to a few scientific academic disciplines. Like, that's it. You can still do a lot of great stuff in R, but Python is much bigger and more diverse.
Yeah, you can do statistics in R, same as in
Yeah.
Python.
A
But
lot of the same
Python is
things you can do.
yeah, Python is a general programming language. Okay. Okay, well, thank you for coming.